So let's talk about some general key concepts in electricity to help give you a foundation for future classes and just kind of general immutable laws to kind of help you understand electricity, what things can change, and what laws are immutable. So the very first theory that we're going to talk about here is the principle of the conservation of energy, also known as the first law of thermodynamics. Basically, the first law of thermodynamics states that heat is a form of energy, and thermodynamic processes are therefore subject to the principle of conservation of energy. This means that heat energy cannot be created or destroyed. It can, however, be transferred from one location to another and converted to and from other forms of energy. So we're never creating new energy, we are simply converting it from one form to another. Second, Kirchhoff's first law, also known as the path of least resistance, essentially says that electrons will follow the path of least resistance. Contrary to popular belief, electricity takes all paths available, but in inverse proportion to the impedance of those paths. The magnitude of the current flowing in any path depends on the path's voltage and impedance. The lower the impedance, assuming that voltage remains current and constant, the greater the current. Conversely, the higher the impedance, assuming that voltage remains constant, the lower the current. So electrons are going to go where it is easiest for them to flow and where there is least resistance. Electricity cannot be stored. Electricity cannot itself be stored on any scale, but it can be converted to other forms of energy which can be stored and later converted back to electricity on demand. This comes back to the differences between primary and secondary energy. We typically convert electricity back to a primary form of energy and then reconvert it back to electricity. Some electricity storage systems would then include battery, a flywheel, compressed air, pumped hydro storage, but these systems always require conversion of secondary energy back to primary energy and then back to secondary energy when needed. Now, the economics of electricity storage on a large scale have become a major focus of attention as intermittent renewable energy sources are becoming much more prevalent. So this is going to be an area that we are going to talk about further in other classes, the idea of energy storage and maybe the misnomers between energy and electricity storage, but that will come in future classes. At a high level, it's important to understand that energy always needs to be converted back from a secondary source to a primary source to be stored and then converted back from primary to secondary energy to be used when we're talking about the electricity grid. Fourth, Ohm's law. This concerns the relationship between voltage, current, and resistance in essentially any direct current electrical circuit, and it was discovered by the German physicist George Ohm. George Ohm found that at a constant temperature, the electrical current flowing through a fixed linear resistance is directly proportional to the voltage applied across it, and also inversely proportional to resistance. The relationship between voltage, current, and resistance forms the basis of Ohm's law. This law is used extensively in electronics formulas and calculations, so it's important to understand and accurately remember these. We will discuss now a few further formulas in the next kind of slide.